All right, so here's a little more practice on trig ratios. Okay, so remember SOHCAHTOA gives you your ratios, and then Pythagorean theorem helps you find all the sides. And then your bow tie helps you realize what quadrant you're in, because remember, you're always in something that looks like a bow tie, and your angle is always at 0, 0. Okay, so your triangle is going to be one of those four right triangles when you do this. Okay, and these all three go together. If it's not a bow tie, then it tends to be the unit circle, right? Kind of about 40% of the problems end up being this, 40% this, and then the other, I don't know, the other 20% end up being other stuff in trig. All right, so let's look at this. They give you a point, so you're going to go -2, 1, 2, and then up 4, 1, 2, 3, 4. So go back to up 4. So I'm just plotting that point. But again, you're going to draw a triangle here. These are vectors. You're going back 2, you're going up 4, and then right there is your bow tie. So then the next step is you need Pythagorean theorem. You cannot get negatives in Pythagorean theorem. Sometimes you add, sometimes you subtract. Here I know x and y, or a and b, so I'm going to add and square root to get this guy. So -2 squared, no matter what you do, that cannot be negative. 4 squared is 16. 20, I get the square root of 20, which, again, to rationalize these things, you do the square root part that can come out and the part that can't. This is going to be 2 radical 5. And the hypotenuse can never be negative. All right. So at this point, we want the 6 trig ratios. Okay, so we're going to have sine of our angle, cosine of our angle, tangent of our angle, right? And then we're going to flip those. I'll come write these over here. S goes with C, so cosecant of our angle. C goes with S, secant of our angle, and cotangent of our angle. All right, so these are 6 trig ratios. All right, so SOHCAHTOA, here I am. Opposite is 4 over hypotenuse. We'll make them pretty later. So CA adjacent, -2 over hypotenuse. And tangent is what? Opposite over adjacent. Okay. Then I'm going to reciprocate or just flip. I'm not going to do it here. I'm not going to say like, oh, cosecant is hypotenuse over opposite. I'm just going to flip what I got for sine. So this is going to be 2 square root of 5 all over 4. 2 square root of 5 over -2, and we'll make these pretty, and this will be -2 over 4. Okay, so now let's make them pretty. I'm going to cancel. A 2 goes in there, 1. And you 2 over the square root of 5, my math lab, Newton, they may take it. Otherwise, usually we rationalize it and get, what, 2 square root of 5 over 5 to make it pretty. Okay, here the 2's cancel. There's an invisible 1 there. Again, we rationalize, so square root of 5, that's going to be what? Negative square root of 5 over 5. And then this guy is just a -2. Okay, now notice we're in this quadrant, which is what? A negative, positive. You go back and up. So my cosine should be negative. It is. My sine should be positive. It is. And tangent should be negative because a positive divided by negative. All right, now let's look at these guys and clean these up a little bit. 2 goes in there twice, so square root of 5 over 2 is a little prettier for that guy. 2's cancel. We don't leave negatives in the denominator, so negative square root of 5 is good for that guy. And then this one, -1/2. Okay? All right, so that's the process. All right, let's look at the next one. Okay, the next one says tangent. Now, that might not look like a ratio, but stick a 1 under it. It is. So we have SOHCAHTOA. We know we're going to do Pythagorean theorem with it, and we know we're going to have a bow tie. Okay. And the reason is, like, this isn't R in the unit circle. It's not like square root of 2 over 2 or anything like that. All right. So where am I? I am in quadrant 2. So I'm going to draw my bow tie right there. Sine is what? Or tangent, sorry. Tangent is OA. So here's my theta. Opposite is across, opposite and adjacent. Now, where does the negative go? Well, you got to look. I am going back, so that's negative. This guy's a +3 because he's going up. All right. Pythagorean theorem, again, I know opposite and adjacent. I don't know hypotenuse. So in Pythagorean theorem, this is going to be an adding one again. I'm not going to subtract. 3 squared, and then -1 squared. And again, no way to get negatives on Pythagorean theorem here. 9, negative times negative is a positive. Square root of 10, square root of c squared. All right, so I get square root of 10 for my hypotenuse. All right, so now I'm going to do my 6 trig ratios. Okay, so I'm going to do sine, cosine, tangent, and then I'm going to do S goes with C, cosecant, secant, and cotangent. And again, these are just answers to division problems. They're just ratios. So you just look at your picture and you do the SOHCAHTOA part. Okay, so sine is what? Here I am, opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, I know, is a -3. That was given. All right. So now I'm going to flip them or reciprocate them. So I'm going to look over here. This is what? Square root of 10 over 3. This is square root of 10 over a -1. And this guy is put an invisible 1 under there, -1/3. All right. So let's just make them a little prettier. Rationalize this one, square root of 10, square root of 10. So I'll just write it over here. So the sine of theta is what? 3 square root of 10 over 10 is prettier. This guy, square root of 10 over square root of 10. Cosine of theta is what? Negative square root of 10 over 10. That's just a mark. Here, you just probably write, -3. That just looks a little nicer. For cosecant, we're good, right? Cosecant theta, square root of 10 over 3 is rationalized, right? There's nothing wrong with that. This one probably only I would do is bring the negative out. Negative square root of 10. We don't usually divide by negative, and you don't need to divide by 1. And then cotangent is fine the way it is, -1/3. Okay, all good. All right, let's look at the next one. And I just need a piece of paper to write on so it doesn't go. All right, let's look at the next one. Terminal side, and this one's supposed to be -5 there. All right, so where am I at? Well, I don't need to tell you because you're graphing it, right? So I'm going to go over 2, down -5. 1, 2, 3, 4, 5. So 2, -5 is right here. So I'm going to draw +2. I'm going to go -5, and then there's my bow tie, okay? And again, your angle that you care about is always right there. All right, Pythagorean theorem. I know A and B. I don't know the hypotenuse. So this is not a subtract kind. This is just solving for, A, B, and C. So 4 plus 25. Again, no way to get negatives. 2 times 2, -5 times -5. And what is it? 29. Square root of 29. So my hypotenuse is the square root of 29. All right, so now I'm going to do my 6 trig ratios. So I have sine, cosine, tangent, and then over here I have cosecant. C goes with S goes with C, and cotangent. These are just the reciprocals, not inverses. You're just flipping it. Just a reciprocal, like 3/4 and 4/3. Those are reciprocals. All right, so now look at your picture. Okay, here's your angle. So sine is what? Opposite over hypotenuse. We'll clean it up later. Adjacent is touching over hypotenuse. Tangent is what? Opposite over adjacent. Now, again, I'm not going to look at my picture. I'm just going to flip these guys. So square root of 29 over 5. And I'm going to go ahead and put the negative on the numerator just to clean it up right away. This is square root of 29 over 2. And this guy is what? +5/2. So that's going to be 2/5. Okay. So these are all pretty the way they are. Here, I'll just rewrite my 5/2. Here, again, rationalize square root of 29 top and bottom. So you get 2 square root of 29 over a 29. Same thing here, square root of 29, square root of 29, -5, square root of 29 over 29. Okay, there you go. All right, and on mine, if you don't clean it up, I'll probably take like, I don't know, 1/4 off or something like that. All right, let's look at this one. Okay, cosine of angle X is 3/4, and it's in quadrant 4. All right, so we're over, here's our bow tie right there. So so adjacent is 3, hypotenuse is 4. Okay, so this is a subtract Pythagorean theorem because I know my A, I don't know my other side, but I know my C, right? And that's what, 4? So this is 9 plus b squared equals 16. What is that? Is that 7? And then square root 7. Oopsie. So square root of 7. Okay. And I need to watch my positive and negatives. This is to the right. This is down. So it's negative. All right. Because again, think of vectors, movement. All right. So then again, sine, cosine, I guess I should call it x, tangent. C goes with S goes with C, cotangent. Okay. Well, cosine I gave you 3/4, and again, to flip it, that's pretty as is, okay? Sine, again, here's your angle. So SOHCAHTOA, opposite is the negative square root of 7 over the, what, hypotenuse? And tangent is what? Opposite over adjacent. All right, so these are actually all pretty. When I flip them, not so much. -4 over square root of 7 and what? -3 over square root of 7. So these are all pretty. These I have to rationalize. So square root of 7, square root of 7. So that's going to be what? -4 square root of 7 all over a 7 for that guy. This one's pretty. Here, rationalize square root of 7, square root of 7, -3 square root of 7 all over 7. That's pretty. All right, and again, you can check your signs. You're positive and negative, right? You're to the right and down. So cosine should always be positive, which it is. Sine should be negative, which it is. And then tangent, a negative divided by positive should be negative. Are those? All right, let's look at the next one. All right, now here, sine is, we're in, where are we in? Quadrant 2. But notice you have square root of 3 over 2. That should ring a bell. That should be like, oh my gosh, I don't have to draw a bow tie because you know the bow tie for this guy. You know everything about this bow tie because it's on the unit circle. This is a half square root of 3 over 2, and you know the hypotenuse is 1. I mean, you know this. This is on the unit circle. So to find the 6 trig ratios, sine, cosine, tangent, you don't actually have to do anything. Sine, this is alphabetical, C then S. Cosine is what? Half. Sine is square root of 3 over 2. Oh, we're in quadrant 2, Julie. Oh, sorry. Let me, shoot. All right. I just crossed off and fixed it. I can find a way on this recording device to change it. Now, on tangent, it's sine divided by cosine, which you multiply by the reciprocal. So negative square root of 3, and I have a negative on my half. So we're actually over in quadrant 2. I didn't read that till later, even though I wrote the worksheet crazy. But so if I'm in quadrant 2, I'm back and I'm up. So this is negative right there. That's a negative, okay? And then that, and then to flip them, so cosecant would be 2 over the square root of 3. Secant would be a -2. And cotangent would be a -1 over square root of 3. All right, and then I would just rationalize. So square root of 3 over square root of 3, so that'd be what? 2 radical 3 over 3. That one's pretty. This one, square root of 3, square root of 3, negative square root of 3 all over 3. Okay, and I would put the tangents all the way around the outside of your unit circle. This one you probably wouldn't even have to draw. Just use your unit circle. All right, same thing here. -45, you should be like, oh my gosh, I know that. -45 is what? Square root of 2 over 2, you're going to the right and down. All right, so you should know all of these, right? Just by, you don't need a bow tie because if it's on the unit circle, that is your bow tie, right? Like you know it. So sine is negative square root of 2 over 2, cosine square root of 2 over 2. If you take this, divide by this, tangent's a -1. C goes with S, so that's what? -2 over radical 2. Same thing here. This is going to be flipping that guy, so that's what? 2 over radical 2. And if you flip a negative, you still get a -1. All right, make these two pretty. Square root of 2 over 2, negative square root of 2 over 2. And the 2's cancel, so you get a negative square root of 2. Square root of 2, square root of 2, I get 2. Radical 2 over the square root of 4, which is 2. Those cancel, so that guy's a square root of 2. Notice if they're on the unit circle, you don't really even need to draw the bow tie. You can just use your unit circle. But if it's these other types, like up here where I give you a terminal point or I give you a ratio that is not on the unit circle, then you are drawing a bow tie, you know, and you are trying to figure those puppies out. All right. Hopefully that helps if you needed some extra practice.